Hi, welcome to this lesson on statistics regression. Let's have a look at using a calculator for regression analysis. So how do we calculate this straight line equation that we spoke about in the beginning when we are looking at linear regression analysis? Well, we call this the linear regression line of best fit, or often just the least squares regression line. And this least squares regression line is of the form, we read this as y hat. So that little hat on top of that y is called y hat, and that's equal to a plus bx. The y hat is what we call an estimator in statistics. So it estimates values based on already established data points. Okay, and it's calculated as follows. Now, a lot of you will ask, where do we get these values for a and b from? Where do they come from? So to answer your question, these values for an a and b are actually derived using a method called the least squares likelihood estimator. Now, it involves some semi-complex calculus to do, right? So we're going to set derivatives, maximize equal to 0. However, for our purposes, when you simplify all of those calculations, we get these parameter values for a and b. And if you want to read it, b just says n, which is the number of data points, times the sum of the product of your x and y values, minus the sum of all your x values times the sum of your y values, all divided by n, the total number of data points, times the sum of your x data points squared, minus the sum of your x data points all squared. So it gets a bit quite complex, and similarly for a. However, we do not need to be afraid of these expressions because our calculator can help us simplify the task of finding these parameter values. Okay, your calculator can also work out things like the mean, the standard deviation, and more importantly, what we call the correlation coefficient of your least squares regression line, which tells you basically, looking at the data, how is it correlated between x and y? What's the relationship between them? Okay, and we'll have a look at that. So let's have a look at an example here. Using a calculator, determine the least squares line of best fit for the following data set. So we have 5 learners. Okay, so n equals 5. That's how many data points we are looking at. And we see we have 2 data sets. We have chemistry as a percentage for that specific learner, and then maths as a percentage for that specific learner. So how you read is that learner 1, they got 52% for chemistry and 48% for maths. Learner 2 got 55% for chemistry and 64% for maths, and so on. They say for a chemistry mark of 65%, what mark does the least squares line predict for mathematics? Based off the question, we can actually determine what is x and what is y. Your x will always be your independent variable. This is the variable that you're going to use when you're substituting into your least squares line. Okay, so in this case, they're looking at chemistry being the independent variable, so I'm going to label that x, and maths is y. Generally, it'll either be labeled to you, given to you what x and y is. Otherwise, based on the context of the question, you can deduce which is your x and which is your y, your independent and dependent variables. Okay, so solution, we will need to enter this data into our calculator as follows. Step 1, turn on your calculator. Really important. Okay, so I'm going to just clear everything off here. Okay, so it says, turn your calculator and press mode and then select stat. So if I click mode, wherever on your calculator it shows stats, for me it's 3, so I'm going to push the number 3. Then it says press the a plus bx button and you will arrive at a table with x and y. So on the calculator here, a plus bx is number 2 on mine, so I'm going to click 2, and you see you arrive with this table with x and y values. Next, you want to insert the data according to the table in the x and y column. So again, your chemistry is your x and your maths is your y. So I'm going to read it. So I'm going to put all the x values first. 52 equals, and you can see it goes down across the x values. Don't worry that the y's are showing 0 for now. We will go and adjust that. So the next one is going to be 55. Just make sure you read the table correctly. Then it's 86. Then it's 71. And then it is 45. Okay, I push equals. Now I'm going to just click down on my arrow so it'll come back up here. Then click right. And now I can populate the y values associated with those x values. So make sure you do it in the correct order. Otherwise, you will mess up the calculation. Okay, so now it's going to be 48. Then it's going to be 64. 95, 79, and 50. Okay, and you can just do a double check, go across your data, make sure the data points are lining up. Once you are done with that, the next step tells us to clear the screen by pressing AC, which stands for all clear. This will save your data in the background. All right, so I'm going to click AC and, okay, there we go, AC. Now you'll see it's got stats on the top there because we've saved something in the statistical computation. Okay, now it says press Shift 1. So Shift, and the reason I push 1 here because on my calculator, stat/distribution is 1. So whatever your stat button is on your calculator, you're going to press Shift 1. Now you see you get all these different types of information here. We want to choose whichever number is regression. So in this case, it's number 5 on my calculator. Now you'll see it gives you 5 different values. The A and the B are exactly those parameters that we are looking for. All right. So if I push A for 1 here, and I press equals, you can see I get negative 5.065, so on. So to 2 decimal places, unless told otherwise, I can round that off to negative 5.07. If I want to get the B value, I'm going to click AC again, Shift 1, regression B, and then you see I get 1.169 and so on. So to 2 decimal places, that's 1.17. So the equation of your regression line, remember, is y hat equals A plus BX, always. And then I substituted the values for A and B. Okay, step 7, to get a good estimate for the predicted value when your chemistry mark X was 65%. You can use your calculator, so you can substitute it directly into this equation, but because it was rounded off, you'll get a rounding off difference in your solution. So if you want to be exact, what you can do is click AC here. So you can push the number you want to substitute for X, in our case 65. Then click Shift Stat, regression, and wherever your number is for the y hat, you'll click 5. Okay, it doesn't mean 65 times y hat, it just means you're looking for the estimated value of y when x is 65. That's what this expression means. So if I push equals, I get 70.94, so that's approximately 71%. So notice in our table, we didn't have a chemistry mark of 65%? Yes, we didn't have a mark of 65%. However, for this learner 6, for example, we can predict based off of these values that they would get around 71% based off of that regression, based off of this line here, which is our regression line. All right, and then to get the correlation coefficient, again, we're going to click AC, so that'll clear everything off. AC always clears everything off. So Shift 1, and we're going to choose the regression again. So if I click 5 for regression, we see that now I'm going to be looking at number 3, which is going to be this little R value. So what does that R value determine? That tells us the correlation coefficient. So if I click 3 here on my calculator, I get 0.971, so on. So to 2 decimal places, that's about 0.97. What does this tell us about our data? Well, it tells us that we have a very strong positive correlation because it's a positive value and it's quite high, it's close to 1. So what can you conclude statistically from this evidence? Well, there is strong evidence to suggest that a good chemistry mark will also produce a good maths mark. And when you think about that in reality, it sort of makes sense. If you're doing very well in chemistry, you might be doing very well in maths because you would be doing a lot of calculations in chemistry. All right, so we can also use what we call a scatter plot to show the spread of that data and how our line of regression fits in. So these red data points, those are the 5 learners that was given to us. Notice that this blue line, and I just put stars here to indicate actual lines on the blue line, the red data points you can see, they are pretty close, sometimes almost look like they're touching the blue line. And that's how you know you've got a good line of best fit here. Okay, so it predicts marks based off already established data. That's the use of linear regression analysis. Okay, and you can see for 65%, when you go up here, you can see it's very close to 71% based off that scatter plot. Okay, so you can make sort of predictions based off of this linear regression line. There are some pitfalls sometimes. If you have values that are very far out, your estimates might not be pretty good. And that also happens when your values are very far out in that direction as well. Your points might not be good. So usually, if you're calculating estimations that are close within what you already have as established data, the estimated or predicted values will be pretty close to what you would expect in a real world setting. If they're too far out, what we call outliers, then that prediction often fails a bit. Okay, and just as a summary for the correlation coefficient, the strength tells you the meaning, so no correlation, very weak, weak, moderate, strong, very strong, and perfect correlation. And these are the R values you expect for that strength. And again, this is all the positive side, so positive R values, and all the negative R values will tell you. Again, so let's say, for example, R was negative 0.67. Okay, so that lies in between over here. So I would say that that has a moderate negative correlation. If R was 0.31, that lies in between here, and I would say that has a positive weak correlation. Okay, so based off that correlation coefficient, we can make some sort of statistical suggestion based off that data to indicate the relationship between the two variables. Okay, so that's been using a calculator for regression analysis. I'll see you in the next one.